So here it is. Our review for quiz number 6. So the first one we have to solve by graphing. Boo. Yes. Yeah, sure, why not? All right, so luckily both of these equations are in what form? Nope, not point slope. I get where you're going with that because it does give us a free point. What form are these in? Y equals mx plus b, which is what form? Slope intercept, because it gives you the slope and the intercept, right? So let's have this one be red.
Can I have red?
No. So plus 3 is the y-intercept. 1, 2, 3, right?
4, 5, 6.
And then I go up 1 over 1 for my slope. And if I keep doing that, I get an accurate line, which is what we need to do. Because if our lines aren't accurate, we're not going to be able to see where they intersect. And that would be bad.
Maybe we should turn the lights back on.
What do you mean?
Wow, stupid decisions made by high schoolers. Shocker. All
Oh,
right.
that even worse.
Turn it
Shut
back
up.
Maybe we should turn the lights back off.
Nope.
No.
Mm-mm.
I still can't see. I don't have contacts or glasses in. I'm literally struggling. I'm literally just blind.
All right, so there is the red line. Y equals x plus 3. Yes, I can. All right, Tide Pods, here we go.
Oh, that's my favorite snack.
That's my fun.
What's your question? All right, everyone shut up now. We have questions for real. So I got the first point because this is in y equals mx plus b form. Where this is the slope, 1, right? And this right here is our y-intercept. So hits the y-axis at 3. Cool? When it's in that form, it gives you that for free. Shion, how you doing?
What? I'm good.
You sure?
Yeah.
Our slope is 1 over 1 because there's a 1 in front of that x. So up 1 over 1. Right? Our slope here is 1 over 1 for the red equation. For the blue equation, our slope is down 1 over 1, right? Because it's negative 1 over 1. Is everybody cool with that? Yeah. Our y-intercept for the second one is negative 7. So we're going to hit at negative 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. And our slope is down 1 over 1. So down 1 to the right 1.
Wait.
Now you'll notice that never hits the red line. So we need to do the reverse, right? Nope. We got to do the reverse. Up 1, left 1, right? Extend that line. It's down 1 over 1, but we can also do the opposite. Up 1, left 1. Down and then right. So, Caden, the slope is negative 1 over 1, right? Okay, so the top part's our rise, so we go down 1, because that's negative. And the bottom part is positive. So it's to the right 1. If it was both negative on top and the bottom, well, 2 negatives make a positive, so it would be 1 over 1.
It'd be the same
Okay.
line.
So they do intersect. And it looks like the point of intersection is at negative 1, 2, 3, 4, 5 to the left.
Negative 2.
Negative 2. Cool. That's where they intersect. That's the solution.
Yeah.
And you can check that because if you plug in negative 5 to either equation, both equation does pop out negative 2 for y. All right, everyone shut up. Quiz is tomorrow. Don't bomb this. This is way too easy to be bombed. Let's make sure we get this. Number 2.
If it's too easy, why
I
are
don't
we
get
teaching
how to
it?
graph it.
Yeah.
That's the only thing I don't get.
What form are these equations in?
Standard.
Standard form, right? Where x and y are on the same side.
You don't know me. You don't know me.
Yeah, I don't get how to number.
All right. I'm going to say it one more time. I need everybody to shut up so I can teach because they can't hear me. So stop talking. So the slope here is 1 because it's 1x. And the slope here for the blue equation is minus 1. So minus 1 over 1.
Yeah.
We better? Jordan, how do you feel? Okay.
Ow.
Number 2. It's in standard form. So the easiest way to graph it in standard form is to find the x and y-intercepts. Now, we could rearrange this to get y on its own, so it's in slope-intercept, right, and graph it like we did the first one, but that's going to be more work. I'd rather just graph it the way I know how, which is to find the x and y-intercepts. What do all x-intercepts have in common? 0 for the y, right, because they're on the x-axis. So if we plug in 0 for y, what's 3 times 0? 0. So we get 2x equals negative 12, which means when we plug in 0 for y, what do we get for x? Negative 6. So that's the x-intercept. Oh, sorry, the y-intercept. Oh, no, I goofed it. We plugged in 0 for y, and we got negative 6 for x. There we go. My bad. So that's the x-intercept, negative 1, 2, 3, 4, 5, 6 on the x-axis. Right, that's our blue equation. And now I'm going to find my y-intercept by plugging in 0 for x. So if I plug in 0 here, it goes away, right? I get 3y equals negative 12. So what's y going to be?
4, negative 4.
Negative 4. Because it's multiplication, not adding. 3 times negative 4 is negative 12. Okay, hold on one second. So, Caden, stop writing stuff down. Let me help you out, okay? So, the easiest way to find 2 points, which is all you need to make a line, when it's in this form, is to plug in 0 for one of the variables, because 3 times 0 is nothing, right? And then we can easily find out what x is. Divide by 2, we get negative 6, right? So 0 for y, negative 6 for x. There's a point. Another way to get a point is to plug in 0 for x. 2 times 0 is 0, so it goes away. We have 3y equals negative 12. We divide by 3, we get negative 4. So 0, negative 4 is the y-intercept. And again, 2 points make a line. Bless you. So there's the blue line. 3y plus 2x equals negative 12. Now let's go get our red line. That's this guy, the bottom equation.
What's this?
We didn't need the slope. We just graphed our 2 points, and we drew a line.
That's negative 3.
Negative 4. Oh no, did I screw it up?
Yeah.
That's not good.
Yeah.
That's not good. I miscounted. I did negative 3 when it should have been negative 4. So ignore that blue line,
Oh, I did it.
and we're going to use this blue line. My bad. That's the one we want. Yikes. Big yikes. This is why we don't like graphing for solving. All right, so now we're going to take this. Let's plug in 0 for y. So we plug in 0 for y. We get negative 3x equals 18. Divide 18 by negative 3. What do we get? Negative 6. Now let's plug in 0 for x. We plug in 0 for x. That goes away. And what we get is 2y equals 18. So we divide by 2. What do we get? 9. So they're not the same line. At least it doesn't appear to be. Negative 6, 0. And 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So where do they intersect? At negative 6, 0, right? Yeah, well, I mean, they could be the exact same line, right? If we had gotten the exact same x and y intercepts, then it would have been infinite solutions, right? Well, right, yeah, and you can be like, nope, they're not going to be the same, right? So they intersect at negative 6, 0. That's true. So the intersection point is negative 6, 0. Are you feeling a little bit better? No?
Yeah.
How'd you get the red number?
This?
That's the other equation.
All right, Troy, I'm going to walk you through what I did. We're going to find out where it hurts, okay? So I'm going to plug in 0 for x, and that's gone. So now I get y must be negative 4, right? Or, yeah, negative 4. Cool? I'm going to plug in 0 for y, and I get that x must be negative 6. I plot those 2 points, I draw it correctly, and right. Same thing here, plug in 0 for x. That's going to get me 9 for y. Plug in 0 for y, that's going to get me negative 6 for x.
You can do it.
Draw 'em. That's where they intersect. Negative 3 times negative 6 is 18, right?
Good.
Oh, okay.
Better? Okay, good.
Yeah.
That's okay. That's okay. Sometimes it just takes a while to see it. It's like those optical illusions, right? We good? We're going to move on to the next page in just a second. Again, this is not homework, so you don't need to copy it down.
I'm still copying it down so I have the right answers.
Why?
'Cause-
Are you gonna study?
Yeah.
Really?
Actually, let's start.
That's awesome.
So I don't think I just so high on class.
That's what he says, but.
I mean,
Shut up, Mitchell. I'm actually. I'm not playing pool today.
here we go. Number 3.
I was.
First of all, what form? Hold on a second.
Y equals mx minus b.
Gotta clean it.
One is
What's the top form?
Point slope.
Point slope. So we get a free point at 3, 3. Well, it's these guys with their signs changed. And if you're not sure if that works, what happens when we plug in 3 for x and 3 for y? Well, 3 minus 3 is
Yeah.
0. What's 0 times 3? 0. So we get 0 on the right side. What happens when we plug in 3 for y? 3 minus 3 is 0. So it works, right? So that must be a point.
I don't get it.
Point slope form is this.
HK.
Right? Where the signs are different.
H would be Y. No.
Whoops, sorry. Flip. I wrote it the wrong way.
Yeah, you
So
didn't tell
K
us
would
what
be
was
Y.
first one.
No.
My bad. That was not on
That
purpose.
confuses me.
If you'd rather write it like this, that works too. If you don't like that, distribute the 3 and get it into a different form, right?
Yeah. But then what do you do with the other 3 on the other side?
So, if you don't like that, let's take this and let's move it to a form we do like. That's going to get us this. All right, so there's a way to graph this without touching it, but you guys didn't like that. So what I'm doing is I'm taking this and I'm moving it into a form we do like, okay?
Yeah.
I distributed the 3. Okay, so I distributed the 3, Jordan, right? And now I'm going to add the 3. And now it's in a form we understand, right?
Why? Let's explain.
That's the same as the other one too.
How'd you get
So
negative
it's
6?
infinite flow.
We'll get there in a second, yep.
And you said that-
Add 3 to negative 9, I get negative 6. Okay? Now, Caden noticed that in this form, we have 2 equations that are exactly the same. The blue equation is exactly the same as the red, isn't it? If they're exactly the same, then they're going to overlap constantly, right? They're going to be the same line when we graph them. So, infinite solution. So y equals 3x minus 6 is this. 1, 2, 3, 4, 5, 6 down and up 3 over 1, right? So when we graph them, they're going to overlap. Which means infinite solutions. They're always agreeing. So yeah. Convert it to a form you do like if you don't like that form, right? But in point slope, that gives us 3, 3. 3, comma, 3, if I drew my line better, is on that line. And then we can use the slope to find another point, right? Let's look at 4. The top equation is in what form? Okay, so we can just go ahead and graph that, right? Down 5, 1, 2, 3, 4, 5. And our slope is down 1 over 3, right? I'm going to keep doing that so it's as accurate as possible. The bottom equation is in what form? Nope. Standard form, right? And the easiest way to graph something in standard is to find the x and y-intercepts. Now, we could convert this to look like slope-intercept, right? We just get y on its own. You could do that if you'd be more comfortable. What I'm going to do is I'm just going to plug in zeros and get 2 points and then draw my line. So if I plug in 0 for y, I get what for x? 12. So that's going to be 12 comma 0. If I plug in 0 for x, I get what for y? 4, right? 6 times 4 is 24. So now I have 2 points and I can draw my line. 12, 0 is here. 0, 4 is here. 1, 2, 3, 4.
That goes off graph. Wait a minute. Is that
As far as we can tell from this window, they're parallel, right? If we wanted to be for sure, we need to know the slope, right?
Yeah.
Now, they are parallel, but I'll show you how I can check to make sure. I would get in slope-intercept form so I can see the slope, right? So I'm going to, first off, I'm going to divide everything by 2. Because why not, right? You didn't have to, but I'm going to, right? As long as you did everything, it's fine. I'm going to subtract the x. I'm going to divide by 3. Yep, same slope. They're parallel, right?
Are you gonna have to do that on the test?
Nope. If this looks parallel, you're good to go.
Or what?
If you are bad at drawing your lines and it looks parallel even when it's not, yikes. So no solution. They never intersect. How are you feeling?
Can you go back to the one before that?
I can in a second. How do we feel about this one? Terrible?
Actually, I'm not kidding, but I'm
Terrible or parallel? What are you saying?
terrible.
Okay. Let's find out where it hurts. All right. Shut up so I can help. Because right now we're doing a lot of other extra talking and you're missing key bits of information. Okay? If you guys were funnier, I would allow it. All right, so don't debate this with me. I can mathematically prove you aren't. All right, so here we are. Graphing this line. Do we feel good about that? Down 5 for the y-intercept. Down 1 over 3 for the slope. Excellent. Graphing this line. Easiest way to graph it in standard form is to plug in zeros, right? If I plug in 0 for y, that goes away. Divide by 2, I get 12. If I plug in 0 for x, that goes away. Divide by 6, I get 4. 12, 0 is here. 0, 4 is here. They never intersect, so they never have a solution. No solution. Are they parallel? Well, parallel lines have the same slope, right? So I checked that. You don't have to. I took this guy and converted him to slope-intercept form, so I can check their slopes. Same slope. Yeah, they're parallel. Yeah.
To put if they're parallel or not.
No, I don't ask you for that. No solution works. Do you feel better? Olivia? Where did it hurt? Do you know? Just don't like it? Or is it?
I think anyone likes it. I did.
You like this part though, right? Graphing that. Plugging in zeros. Is that what's goofing you up? Plug in 0 for x, so 0 for x. 2 times 0 is nothing. That means we divide by 6 and we get y is 4. Better? Okay, same thing here, but we're going to plug in 0 for y. Right? So that goes away. We divide by 2, we get x is 12. Better? Plot your points, draw a line. Good, good. Turn the page. Solve each system by substitution. This is Nevaeh's method.
Substitution is
All right, so we need to get a variable on its own, right? And then switch it out. So if I look at the top one, y is nearly on its own, isn't it?
Yeah, divided by 2.
All we have to do is take this equation and divide everything by 2 to get y on its own. So I get y equals, what's negative 8/3 divided by 2?
-8.
negative 4/3.
You don't have to divide.
You could do negative 8/6 if you want, but then it reduces.
Oh, yeah.
Negative 8/3. I have 8/3. We cut that in half. I've got 4/3 now, right? What's negative 6 divided by 2? Good call. So now we're going to take this. We're going to plug it in for y. Jordan, you doing okay? 3 times whatever y is plus 4x equals negative 12. We're plugging in negative 4/3 x minus 3. Whenever we plug stuff in, we wrap it in parentheses. Now we distribute. That's right. We have negative 4 divided by 3 times 3. Isn't the divide by 3 and times 3 going to cancel?
Negative 4x.
Right? 3 divided by 3, 1 times negative 4, negative 4. 3 times negative 3, negative 9.
Both the plus 4x and negative 4x.
Cancel each other.
Yeah, I can see.
They will, won't they? Minus 4x and plus 4x. 0x, right? So now we're left with negative 9 equals negative 12. Either we goofed or no solution. So the lines must be what? Parallel, they never intersect. How do we feel about the distribution? Are we okay with that? Jordan, how you doing? Yeah, for real? Okay.
What if you end up like with 3 equals 3? Would that be?
That'd be infinite solutions because it 3 always equals 3, right? It must mean they're the same line. Number 6. We already have y on its own, so that's convenient. So we're going to take that and plug it in for y. Negative 3 times whatever y is, plus x equals 9. Well, we know what y is. It's 1/3 of x minus 5. We distribute. What's negative 3 divided by 3?
Negative x.
Negative 1 times 1, negative 1. I'll do it again. Negative 3 divided by 3,
There's no solution.
negative 1. Negative 1 times 1, negative 1. So negative x. Positive 15.
15 equals 9.
No solution now.
Negative x and positive x go away. We get 15 equals 9. No solution. So we must have parallel lines again.
Maybe one of them that has a solution.
Why? Are we okay?
Yeah.
Got a lot of tea going on, huh? Is that the deal? A lot of tea today? Yeah?
Oh, yeah.
We're just preparing to the office to change our schedule.
Yeah, I know.
Alright, I'm going to real class after what?
Everybody's gonna leave.
I made mine.
You did. Oh boy. Solve each linear system by combination or elimination. That's what we did yesterday. That's what you guys seem to enjoy. In order for us to do that, though,
The floor.
we have to make sure our x's and y's are lined up. All right. Make sure you do this because you're going to make this mistake tomorrow. X's and y's need to be lined up and on the same side of the equal sign. So it might look like the y's and the x's are lined up, but that negative 7x is on the right side, and this is on the left. You're going to make this mistake tomorrow. Y and y are lined up, but the negative 7x is on the right side of the equal sign, and the 2x is on the left side. So we need to move that 7x over. So I'm going to write it like this. And then the bottom equation. And now it's lined up. And so now we can do elimination. Already the y's are going to eliminate each other, right? So all I have to do is start subtracting.
So,
Y minus y goes away because that's what we wanted it to do.
5x equals 0.
Negative 5 minus 5 is negative 10.
Wait.
Negative 5 minus 5.
X equals 2.
Classic mistake. Always look back at the sign. X equals negative 2. So the solution is going to be negative 2 comma something. How can I figure out the something?
0.
Plug it in to the original equation. I'm going to plug it in here.
Yeah.
Y plus 2 times negative 2 equals 5. That's going to be y minus 4 equals 5, which means y is 9. You can't just assume 0.
Do you enjoy teaching geometry and algebra more? Like just in general, like not involving students?
I think I enjoy teaching geometry more.
Why?
Because if you like,
The geometry.
I'm not talking about the class, I'm talking about the subject.
It's because it's more advanced.
Shut up so I can hear. I moved over the negative 7 by adding. Negative 7x, I added it to move the whole term over. Yeah, good question. I'm worried.
So am I.
There's a lot of screwing around without a lot of understanding, which is not good.
I know.
Good. Then be quiet so other people can figure it out too. That was a general comment, not specifically towards you. Cool? Next one. Are our x's and y's lined up? No, so let's rearrange them. The 5 y's on the left already, I'm just going to put it out front. So I don't need to flip the sign or anything, right? It's already on the left side. I didn't change the side, so I'm not having to change the sign, right? I didn't move it to the other side. I just switched the order here.
Wait, can we put the 10y minus 6x on top of that?
You can if you want.
That's a little easier.
Now, when we subtract this, is anything going to go away? No, so that's not going to do us any good. So we need to multiply one of these equations so things will go away. If we multiply the top by 2,
It's going to be the same as the bottom.
check it out. So we multiply the top by 2, I get 10 here, negative 6 there, and I get 60 here. They're the same equation. If they're the same equation, they must be infinite solutions. We can just stop right there, can't we? Because what we're going to get when we subtract is 0 equals 0.
You just like your infinite solutions, don't you?
Yeah, why not?
Could you re-explain that?
Yes, so check it out. I needed something to go away. So I wanted the 5 to match the 10, so I multiplied it by 2, right? I had to multiply everything by 2, otherwise that's breaking math, right? You can't just change the equation.
Oh, you have to get one thing.
Everything times 2. Yeah, we're trying to eliminate stuff. They have to match up. Before, they already did. Y matched the Y, right? So I made these match by multiplying the entire top by 2. And I noticed right away, you guys did too, that they're the same thing. Which means when we subtract them, we're going to get 0 equals 0. Which means infinite solutions. Are we feeling better? Next one. Are the x's and y's lined up? No. The 4x needs to move over with to the other side. So 3y plus 4x equals 29. And the bottom we're going to keep the same. 5y plus 3x equals 30. When I subtract, does anything go away? So how do I make things match? Which variable do you want to match, the x's or the y's? Okay, let's make the x's match. What do I multiply the top by to make it match the bottom? If I multiply the top by 3, I get 9, 12. 3 times 30 is 90. Subtract 3 because we overshot it by 3. It's going to be 87.
I multiply the bottom by 4.
Now I have to multiply the bottom by 4. I get 20. 12, that's what we wanted to match, and 120. It did work out, because now when we subtract, 9 minus 20y is negative 11y. 12x minus 12x is 0, right? That's what we wanted. We wanted to eliminate that. Equal sign, don't lose it. 87 minus 120. That's going to be negative 33. I added 3 to get to 90 and 30 more to get to 120. I don't subtract, I add. 3 to get to 90, 30 more to get to 120.
Divide by
90 to 120 is the same as 9 to 12. Right? Then I divide, and I get positive 3. How do I find out what x is?
Plug it back in.
Plug it back in. Let's plug it in here for y. So we get 5 times 3 plus 3x equals 30. That's 15. That means 3x equals 15, which means x equals 5. I subtracted 15 and got 15.
Wow.
30 minus 15 is 15. That's a coincidence.
Very good.
I plugged in 3 for y, because that's what I knew, and I found x was 5.
Yes.
Feeling okay?
Yeah.
All right. 10. Any method you want.
Substitution.
Here's what I would do. I would take this guy and convert him into slope-intercept. So what I'm going to do is take this guy. I'm going to distribute that negative 4. So I get this. Then I'm going to subtract the 2. And now I'm here. I'm going to take that and plug it in for y. Half times whatever y is, plus 2x equals 3. This is what I'm plugging in. Distribute the half. What's half of negative 4? Negative 2x. What's half of 6? 3 equals 3. They're the same line. I don't know, it's fun. Also, it's less work, because if you find it's like 3 equals x, then you got to go back and plug it back in, right? You're welcome.
We have.
Who all needs to go see Streets?
Like,
Really? That many people aren't going to be here? Oh my god.
no.
Go now.
Hey, I'm gonna be here.
Take your stuff and leave.
Bad.
Make sure you check into your homeroom if the bell rings, though. Okay?
Mr. Mac. Mr. Mac. Yeah. You want your eraser? Yes.
Oh god. Sorry. Not in my house.
The office
Teamwork, that was
is
adorable.
about to happen.
Two.
Can you double that?
Oh god, there's 2?
Oh man.
That's what you said.
Hey. I thought you were going for 2 like
Can I get a pass, Mr. Mac, and then?
That's it, try it.
Yeah.
The office is like
Back to this desk, chair say cake and cake. What are you?
Because kids are edgy. Like, there's nothing more edgy and hardcore and rebellious than supporting white supremacy, which is literally like the #1 status quo in this country, right? Nothing more rebellious than
What
that.
time we get out of this class? 35 or
I
31?
don't know.
35.
Why?
Because
I don't know. Oh, 33.
32.
No, it's like 35. Where are they even going?
Alright, if you're gonna go ahead and go ask.
Where are they going?
I want to go ask the county clerk to see if they can schedule change so they can stay in class.
I don't want to stay. I'll go to Mr. Randomites. Either shooting Staples. It was a lot.
Impotence.
It was a lot.
Impotence.
A lot.